This is the Kubernetes top-down coffee course from Sorted Startup. By the time you finish your coffee, you'll know how to deploy a basic Kubernetes application. In this course, we don't discuss the basics of Kubernetes first and then work our way up to the implementation. We do the other way around. We describe a problem, we implement it, and you learn Kubernetes along the way. What we're trying to do here is very simple. We're trying to deploy a Node.js web application which talks to a Postgres database server. And we want this web application to be accessible over the internet to the user. Let's dive in directly into the Kubernetes implementation. So the user would type in a URL in his browser, http://URL. Of course, the browser would convert this URL into a IP address first. That request to that IP address lands up on the ingress. So ingress is the first concept that you encounter if you follow the traffic from the user to the Kubernetes cluster. If you're on the cloud, for example, if you're on the Google Kubernetes engine, they provide a custom implementation of their ingress. If you are on bare metal or you're deploying your own Kubernetes, you have options. You can deploy Nginx as your ingress controller or traffic as your ingress controller. In this course, we are using K3s to set up a local Kubernetes cluster, and it uses traffic by default. But whichever ingress you use, basically it's a reverse proxy. So the traffic lands up here on the ingress, and then the ingress decides where it goes next. So in this case, the ingress would be sending it to a web app service. So now service is an overloaded term in web application world. But here we are talking about the Kubernetes service, the concept of Kubernetes service. So a Kubernetes service is like an internal load balancer. Once you create a Kubernetes service, its IP address never changes. So the user sends traffic to the ingress sends traffic to the web application service, which is an internal load balancer. So now if it is an internal load balancer, it may be sending traffic to multiple instances of our web application. That's what it exactly does. Now we come to the pod, which will contain our Node.js web application. So a pod in Kubernetes is an abstraction over the Docker container. So in Docker, you have a Docker image. If you want to run that Docker image, you say Docker run Docker image and it starts running. In Kubernetes, they added extra features on top of a simple Docker container and they call it a pod. But pod is an atomic unit in Kubernetes, and everything inside a pod moves when the pod moves from one physical node to another. So this web application, Node.js web application, is deployed using a Docker image, and on Kubernetes it looks like a pod. So there can be more than one instances of a pod. If you have more than one instances of a pod running, the web application service is going to load balance traffic between them by default in a round robin fashion. But who creates these pods? How do they come into existence? Who creates this service? Who creates this ingress? How do they come into existence? So for each of these Kubernetes box that you're seeing, for each of them, we need a YAML file. And we are going to deploy that YAML file onto the Kubernetes cluster, which will bring these things into existence. We will see that once we start deploying it. So this Kubernetes pod is again created by another abstraction in Kubernetes called a deployment. We will not go into details for now, but a deployment decides how many copies of the pod will exist. It will also make sure that the physical machine or the VM where the pod is created, if that machine goes down, the pod should be relocated on another machine. So the deployment takes care of that. Again, deployment is an overloaded word, but here we are talking about a Kubernetes deployment. It is a Kubernetes specific concept, just like service here is a Kubernetes specific service. Okay, so the user sends traffic to ingress, ingress sends to the web application service, which is the internal load balancer. It sends to one or more pods which are running the web application. Now the web application needs to contact the database server. So it contacts again a Postgres service. So this is again a Kubernetes service, just like this one was. This Kubernetes service now sends traffic to a pod again, just like you had a web application pod, you have another pod here. This pod is a Postgres database pod. Who creates this pod? Just like the web application pod was created by a abstract Kubernetes concept called deployment, this pod is created by an abstract Kubernetes concept called a stateful set. Before proceeding further into the details of how Kubernetes deployment work, let's have a look at the web application itself. So the web application is a JavaScript Node.js application. Let me walk you through the endpoints. So we have a hello endpoint, which just returns hello world and a timestamp. This is basically for testing, even if the database is not working. So you need some endpoint to get the data back and verify that the application is up. Then you have a endpoint for to-dos. So this is a post request. So this is used to create a to-do. In our case, we just take the name of the to-do and we create it. Once you get the to-do, we insert it into the Postgres database. Similarly, we have a get to-do. So this gets all the to-dos from the database using the select query. Okay, so we have a endpoint to create to-do and to get all the to-dos. We have a hello endpoint for testing, and at the root of the application, we serve a static HTML file, which is basically the app UI. Now, how do we test it? We want to test this application locally. To test this application, since this is a database-driven application, you would need a Postgres instance. So you would need Docker to run it. So you would say Docker run Postgres image, and you would run the application and pass in the connection properties for Postgres to it. A better way for development would be to use Docker Compose. So this is just for testing, mind you. The deployment in production is going to happen on Kubernetes. This is for testing. So we have two services here, the web application and Postgres. Pretty straightforward. The Postgres service says that I want to use the Postgres Docker image, the latest image, and we specify the username, password, and the database to create. We use the standard port 5432, and we specify a volume for it to store data. On the web application side, the only difference is that instead of a Docker image, we specify this build part. So every time you bring up this Docker Compose environment, it is going to look at this Docker file, build an image, and then start it up. So it does a lot of automation automatically built in for you. So let's try to bring it up. Docker-compose up. Okay, database server running, as you can see here. The Postgres server is running here, and this is the web application running. All right, so let me try to access the application over port 3000. Okay, so this is our index.html page being returned by slash, a simple UI. So it works. If I refresh the page, the to-dos are still there. Now let's verify if these to-dos are indeed created in the database. How do we do that? So we have an extension for Postgres already installed in our VS Code. And let me refresh it. Yep, so there's a to-dos table, select. Yep, there is the to-do 1 and 2. So you can see the same to-dos are available here. So the flow is working round trip. So the user can access the web application. The web application sends data to the database and it is coming back from the database. But all this is still in Docker Compose. We are still not in Kubernetes. So what we confirmed is our web application works. The data gets stored into the database. Now let's move to the Kubernetes deployment. Let's look at the folder Kubernetes deployment. So we looked at the web app folder already. The web app folder has app.js. This is the only code that we have for the web application. The other files are for Docker Compose, the Docker file, and the package.json. Okay, now we are going into a new folder, Kubernetes-deployment. All the YAML files that we need for the Kubernetes deployment are stored inside this file, in this folder. So here again, service is an overloaded term here, but we are not referring to the Kubernetes service here. This folder name is just to organize the two entities that we have, that is the web application and the Postgres. Let's go to the web application part. So as you can see, there's a bunch of YAML files, but we'll go through them one by one. So let me open this deployment.yaml file. So let's go back to the diagram, which will explain you. So in the diagram, we mentioned that the user talks to the ingress. Ingress talks to the web application service. This web application service is the internal load balancer. Traffic hits the pod, which is an abstraction over Docker images or Docker containers. These pods, which are basically Docker containers in our case, are managed by deployment. And here you see the word deployment. So this deployment is a Kubernetes abstraction which is going to control the lifecycle of this pod. So all the details of this pod are specified in the spec section. So if you look at the spec section, we say the container, you can have many containers. That is where the magic of Kubernetes comes in. That is where the extra features over a basic container comes in. So you can specify many containers which will be running at the same time, and all these will be part of a pod. And this pod, when a node goes down or some problem happens, this entire pod moves from one physical VM to the other. Okay, so right now we have just one container and we are using this Docker image. How did we create this Docker image? Who created it? I will show it to you in a moment. But first, let's go over the Kubernetes part. Then, after specifying the Docker image, we also need to specify how it needs to connect to the Postgres database server. So we simply pass in the values using environment variables. We pass the Postgres hostname. we pass the Postgres DB username and password. Now, if you notice in these environment variables, we are referring to a secret called Postgres-secret. So this is a abstraction created by Kubernetes to help you manage secrets easily, which are otherwise you need a special mechanism to deal with it. I mean, you have to deal with it, but here Kubernetes helps you by creating an abstraction. So we are mounting this Kubernetes secret into this environment variables here. Now, I want you to notice this Postgres host environment variable. It points to a static string, Postgres-service. If you look at the diagram, the web application pod, which is managed by the deployment, talks to Postgres service. So this Postgres service is a Kubernetes service, which is the internal load balancer, which talks to the Kubernetes pod for Postgres. So this service, once created, for example, the Postgres service or the web app service, once it is created, its name doesn't change and its IP address also does not change. This IP address of the service by default is cluster internal. That means it cannot be accessed from outside of the Kubernetes cluster. So it is an internal load balancer. All right, so this is the deployment. There is this Docker image, and these are the environment variables that the application running inside this Docker image uses to connect to the database. All right, now let's look at the service for the web application. Okay, so our web application runs on port 3000, but this internal load balancer is going to listen on port 80. So this is a very, very short, small YAML file, which just says that any traffic that comes on port 80, forward it to port 3000. And then this is how it knows which pod to send the traffic to. Selector app:web. If we go back to the deployment, we will find the same match labels over here. The same labels here, app:web. So this label and the label on the service has to match. That's how the service knows where to send the traffic to. All right. So we discuss about the service. We discuss about this pod created by the deployment. Now let's discuss about the ingress. So in the ingress configuration, because it's an abstraction provided to us by Kubernetes, there is also something called the ingress controller, which in this case is traffic. So in this YAML file, we're just configuring. This is just the configuration. So this is another good thing about Kubernetes is you just describe what you want in the YAML files. And then there is a controller or a software running behind the scenes, which takes your YAML file and makes it happen. In this case, we specify that we want to use this host name and we want any traffic arriving on this host name to be forwarded to this Kubernetes service. So web app-service. So you can see according to this configuration, if I type in this host name in the browser, that traffic is sent to this service, web app-service. Web app-service on the right hand side will send the traffic to any pod matching this selector. If we go to the deployment, we can see which container or which pods are going to have this label. These pods, which are described below, are going to have the label app:web app. So that is how the whole flow works. The ingress, service, and then the pod managed by the deployment. Now let's start deploying these files. Let me move to the Kubernetes deployment folder. Let me set the correct kubeconfig file. I'm using K3s to run Kubernetes locally. So the first thing I'm going to do is I'm going to create a Kubernetes namespace. So namespace, as the name suggests, is just a grouping of Kubernetes objects within a particular, under a particular name, so that they don't conflict with each other. So it already exists. I just created it, but there is no entities inside it. Let me show it to you. Okay, so it's empty, no resources found. Now let me start creating resources. Web app deployment. Okay, so I just said kubectl-n namespace apply a YAML file, and I chose the deployment YAML file, this YAML file, which specifies the Docker image and these environment variables. Let's see what happens. Let's say get all, so it will show you all the resources in that namespace. So we can see that there is a deployment. This deployment actually creates another thing called the replica set, and this replica set creates a pod, and this pod is the one which is running our Docker image. Let's see if we can verify if this Docker image is running. It should not be running entirely successfully because it's not connected to the database yet, because we did not deploy the database. I'm going to port forward. Okay, so the port 3001 is now running a port forwarding server, which is forwarding all the traffic from port 3001 on my laptop to port 3000 inside the Kubernetes cluster. Okay, so I can see the web application. Let me try to create a to-do. Of course, it fails. If we look at the requests, it's failing with a 500 internal server error. And this is because the database is missing. Okay, so we know that the Kubernetes cluster is now running our web application. Before we move to deploying the database, I would like to deploy the ingress. So just like I deployed the deployment YAML file, let me deploy the service and the ingress. So now let me try to see if I can access it via the ingress. So this is the host name. Let me try to type it in the browser. Yep, I can see my database application, my web application, but of course it doesn't work completely because the database server is still missing. Let's also try to see the logs of the running Docker container. So in this namespace, I'll again say get all. It's going to show me all the things running. So I can see there is a pod. I can see there's a deployment. I can see there's a replica set. So the order is like this. There's a deployment. Deployment creates a replica set. Replica set creates a pod. This comes in handy. You may be wondering why this replica set exists. This comes in handy when you are upgrading. So when you are upgrading and you want two versions to exist at the same time, or when you want to roll back, it's going to be helpful. And there is this service. So we were able to access the ingress using the host name. On a cloud environment, this would be a public IP, and you would have a host entry for that public IP in your DNS provider. Now let's go to deploying the Postgres database server. So I'm going to follow the exact same steps. I'm going to say apply -f, services, Postgres service, stateful set. Now if you're wondering, does the order make a difference? Most of the times it does not, because Kubernetes is a eventually consistent system. So these YAML files just declare in a declarative way what you want, but the Kubernetes cluster makes it happen over a period of time, not immediately. So you can see that these calls return immediately, but then they may be doing something behind the scene in the long term. Okay, so we deployed these two things. Let's say get all again. So now an additional thing is the stateful set / Postgres. This stateful set creates this pod Postgres -0. There is also a new service called Postgres -service. Now I want you to notice here that if we use a stateful set, the pod naming convention is like this: Postgres -0. If you increase the number of replicas, it's going to be Postgres -1, 2, 3, and so on. If you look at the pods created by the deployment, it is web app -a random number. This is because the deployment is used for stateless pods, where you don't store state on disk, or the order of this numbered order. You don't need these numbered orders. This is not part of your architecture. But for most databases or most database driven things like even Kafka, order is important. So this gives a stable identity to this pod, more or less like a VM. So you get a static host name which never changes. In this case, the host name of the pod or the Docker container keeps changing. So that's one difference between the stateful set and the deployment. All right, now let's check the logs and see if our web application is able to connect to this database server. I'm sorry, I should be checking the logs for the pod. Okay, so the last message says that it could not connect. Let's try to access it on our browser. All right, so I can already see the to-do list from the database. Let me try to create one. To-do 1, to-do 2. Okay, so this tells me that it is now able to connect to the database server, and based on the logging infrastructure that we have on the app.js, it is not producing any errors now like it was earlier. So this application is now successfully deployed. Let's go back to the architecture and revise once again what we've done so far. So we started with this requirement. We wanted to deploy Node.js web application which connects to a Postgres database server, and the user should be able to access it over the internet. We discussed the Kubernetes solution. The solution is user talks to a Kubernetes ingress. Ingress talks to an internal load balancer for the web application. This internal web application is formally known as a Kubernetes service within Kubernetes. So the web application service now forwards your traffic to the pods. There may be more than one pods, and these are all stateless pods. That's why we have a deployment, a Kubernetes deployment managing these pods. Then this traffic goes to Postgres service, again an internal load balancer in front of Postgres pods. So this internal load balancer for Postgres forwards the traffic to pods running the actual Postgres database. And that's how this whole thing works.